Hi everyone, thank you for joining. This is Marcos Anasivia here. This is the Oracle Machine Learning Office Hours. So this week we want to talk about some of the new Oracle Machine Learning notebook templates that we have. This week we're going to be talking about the ones for machine learning classification. Today with me we have Mark Hornick and Sherry LaMonica as well. So if you guys have any questions at any time, please don't hesitate to put them in chat or in the Q&A. So the topics, basically, I'm going to be quickly talking about the upcoming sessions. And then we're going to do the follow along OML Notebooks ML classification demo, okay? So the idea is that you guys will be able to do exactly what I'm doing and see what I'm seeing if you have your Oracle Autonomous Database and then you have your Oracle Machine Learning notebooks open, okay? All right, so the upcoming sessions, then, like we said last week, right, we will going to begin this series, right, of the notebooks that we have created, the latest ones that we have put in the examples. So today we're starting with the classification. We're going to then have a regression, clustering, and then feature extraction. We might need more than one, so that's why I'm probably going to do 2 sessions for it. And then we can talk about time series. And then if you're in JPAC, tonight, our time here in the USA, but tomorrow on your time, early time, you're going to see that the Oracle database world is starting. Okay, so there's going to be a session there. I'll be assisting with Q&A. As you can see the schedule, we have actually added for next week a what's new. Right, so that's the last one here for December 7th. We have a what's new in Oracle Machine Learning, and that's because we have had over the past probably a month a few new updates, a few new features on different components. So we wanted to just put them together on a session where we can talk to you guys about all of the different things that are new. Okay. All right. So. And then we are continuing with regression on December 14, and then we're going to break for the holidays at the end of the year. So we're going to probably be doing that on January 11th. We're going to get the clustering and then the first feature extraction January 18. All right, so let's take a look then at the classification templates we have. So if you guys, and I'm going to be going through the software with you, right? But if you were to look at the example templates that exist today, you would find that there are 12 classification demos that contain, specific algorithms and that are specific to a language, right? So if you look at the listing, half of them here have Python, right? OML for Pi, and the other half are SQL based, okay? Now, there is one additional algorithm that is not showing up here because it's going to show up when you're running 21C. So for now, 21C is only available on Autonomous Always Free, okay? And if you have an Always Free 21C release, you're going to see one additional template, which is the OML for SQL XGBoost, okay? So that's because the algorithm is it's new for the 21 release, right? So you're going to see it there. So there are 2 ways to get to the template examples, right? If you get to the Oracle Machine Learning and that's your splash screen the first time you're coming into it, you're going to see that one of the quick actions is called examples. But if you click on the hamburger menu here on the top left, it's also available down here, right? On the under templates, there's something called examples. So what we're going to go and do together is we're going to select one of the examples. So first we're going to filter, right? Because there are 72 examples. So we need to filter out for and search for only the classification one. So we're going to type classif in the search filter, and we're gonna get the list reduced. We're going to pick one of them. In this case, I picked the classification decision tree, and we're gonna select that. But we're gonna click on the lip around the template name. Okay. I mean, you can click. I think you can click inside it, the only thing you should not do is you should not click on the name of it. If you click on the name of it, it actually opens the template itself in a read-only mode. So this might be useful if you don't want to copy, and if you have many templates that you have created and you don't remember exactly, or you're looking for just a little piece of code that you want to copy from it, right? Then that might be useful to open it up, in read-only mode. But we want to actually play with it. We want to edit it. We might want to change things around. So my suggestion is to click on it outside of clicking that link, right? So you're going to see that it highlights in a blue haze around it, and then we're going to click on Create Notebook. Okay. Then when you click on Create Notebook, it's going to suggest to you to give it a name. So we can just give it a name and then click OK. All right. So once you do that, if you don't have any other notebooks, right, that's going to be the only one, but it's going to show up here on under your notebooks, and then you're going to be able to open it up and use it. All right. So we're going to go and do that right now. So right now, I am here and I go to notebooks. I have my first data, decision tree classification, right? But I'm going to delete it just so that we have nothing here, okay? So, and you're going to see that one of the new things that you're going to see around OML is that there's the new notification, right? That pops up on the right and goes away, right? Before it used to be like a band on top here. So in any case, we're going to go and do that. So if you guys have the Oracle Machine Learning login, right, or you have an always free account or anything, and you want to click around and look with me, please do so. And if you guys have any problems accessing this at any time, just let us know on the Q&A, okay? So right here, then I'm going to click there and I'm going to say examples, right, in the templates. All right, so right here then, in the example templates, you can see that everything is here, right? So even if you scroll down, you're going to see there are many pages here, right? And there are 74 total items, right? So what I want to do is I want to search here, and I'm going to type in classif, right, for classification, and I immediately see there is a filter. So if I scroll down again, I see there are 12 items for the classification ones, okay? So as an example, let's open up the decision tree. You see that if I hover my mouse over that box, right, I can click on this and it will select it and it will color it blue, even if I click it in the middle, right? So what I don't want to do is, again, I don't want to click on the name, because if I click on the name, you're going to open it for read-only access, and you're not going to be able to run it, right? But we do want to run it and play with it. So I'm going to click on the middle, and then I'll click on Create Notebook. And then it gives me a suggested name, right? OML for Pi classification decision tree. I'm going to call it example. Okay. And you can normally put comments if you wanted to. That shows up in the listing of the notebooks. So we can say okay, and then again on the right, on the top right, you see the confirmation pop up, right? That comes up and then it will be dismissed. Okay, so this allows you to now create another one, right? And click another one and check out the other examples. So let's go back to notebooks first and then take a look at what that notebook looks like, right? So we go back to notebooks, and here I have, as I mentioned, the name. You can have the comment right there, and we're going to click on it. So one of the most important things you guys have to remember every time you open a new notebook is that you have to check the interpreters, right? The interpreter binding. So, well, first things first, right? It's going to open up here. And, you know, as an example, you can see that it actually was executed, right? So you can see the results. And we left it right there like that because then you don't really need to run it to see the results. You can definitely see what is happening, right? You can scroll down and see the results, right? What is the data set and all that. But if you look closely, right, this one was run by OML user on August 23rd, right? So this is not you, right? This is the template that was executed, and you have that that quality there, right? That the output, just so that you see it. Now, what we're going to do is we're going to click on interpreter binding on the top right, because we need to make sure that whatever interpreter you're selecting here is the one you want to use, right? So normally, if I'm not in a hurry, if I don't have any issues with it, I would use low. Low is fine, and low allows you to do many more people, you know, hitting that autonomous database without problems. So normally low is fine. For this session, I'm going to use medium, and again, it's optional, right, to you guys. These volumes of data and this kind of things probably do not need high. So high might not give you any much benefit above and beyond what medium can do, right? With low, remember that you don't have any parallelism. So low gives you definitely less capabilities for running parallel threads behind the scenes on the model building. But medium will give you that enough. And then with high, the only problem is you potentially could overrun that database, right, with your user without really needing to, and potentially step on other people's feet that are trying to run things there as well. So I'm going to keep it in medium, and that's fine. But you got to make sure that one of these guys, at least one of these guys, is selected. Okay. So now that I see that one is selected, I can click and run all paragraphs, right? So what we're doing now is we're just running everything. Again, just to make sure that everything is running fine. So now you can see that everything should say ran at November 30, right? And what time in this case is my local time, right? I'm in Miami, so this is my Miami time right now. But it should say your local time, right? So again, we're going to scroll down here, and for all of these classification, right, algorithms, what we're doing is we're using the supplementary demographics under the SH schema. So that's a very well-known data set that has things like education, occupation, household size, years of residence. And our target is going to be these affinity card, right? We're trying to predict whether or not the customer would accept an offer for an affinity card here. And then you have all these other potential columns, right? That input attributes that would make sense, right? So the shape is 4,500 records, right? And 14 columns. And then if you scroll down, you can see affinity cards. So, you can see 1,000 people accepted versus 3,400 did not. That's your proportion here, right? Is 1 to 3.5 that accepted. And then other statistics and other columns like household size. So you can see, for example, that if the household size is 1, then there is very, very little, right? There's only like 11 people that accepted your offer. Versus if the household size is 3, then you see there's a lot more people that accepted the offer, right? In proportion to the people that did not accept, right? So that just, again, gives you an idea. And that's what this algorithm is going to try to do, right? So the decision tree here is going to try to identify the ones from the zeros, right? And separate them. So that's what the decision tree is going to try to do, right? So in this case, we're going to just select, all this is doing is selecting the columns that we want to use. And then creating a train and test, right? So we're splitting 60-40. So we create a train and a test data sets, and then we create the train X and the train Y, just because that's the way Python likes this, right? So we create additional additional pandas data frames, right? But these are all those virtual pointers, right? So these are pointers to Oracle database views, right? So we're creating views behind the scenes to point to these guys. So these guys are all proxies. And then for the test, we do the same thing, test X and Y, and then we're going to build the decision tree, right? So what we have done here now is a little bit different than before. We build that decision tree for you, and we run a score using the test now, right, to show the accuracy, right? So this is the accuracy of that model on the test set. But you see that you have the settings equals nothing here. And the most important thing we've done for all of these algorithms is we have added for you some variations on those settings. And that the idea was that because, you know, normally if you want to understand which settings are available, you would always have to go to the documentation, and the documentation, sometimes they don't have it in the phrase, right? Use it in a phrase. They were not using that in an example. They would just show you how to call it. So what we have done is we're showing you the examples of the possible setting overrides for decision tree. So we have links for you to the documentation. So if you click on here, you go to the algorithm settings. If you click here, you go to the shared settings. So there are some shared settings like row weight, right, or missing value treatment. This is common across all of the algorithms. So the name of the option is going to be the same regardless of the algorithm, right? But then the decision tree specific algorithms. So we just copied a few of the comments. So for example, tree impurity metric, right? So you're going to do Gini or you're going to do entropy. So there's an explanation now here, just so that, you know, again, extracted from the documentation, but to make it easier on you guys so that you guys don't have to go to the documentation to look at it, right? You can just look at it from here and see that over there. So we have things like the split criterion, the max depth of the tree, the minimum percentage that does per node, right? So at the leaf level, the minimum number of rows required to a split, right? So that's the percentage, right? And then the minimum number of rows in a node, and then other the minimum records, right, for a split and things along those lines, right? And finally, the maximum number of bins. So this setting in particular is common across decision tree and random forest as well. Okay, but random forest has a 254 maximum number of bins per attribute, just because you're building many trees. You might be building hundreds or thousands of trees, right? While in the decision tree itself, you can go all the way, you know, it can go crazy to all the way to 1 million of bins, but that might not make sense either. But that's basically it. So now we're going to show you another decision tree built using explicit settings, right? So we're going to specify the settings down here, and putting a few settings over here, you can take a look at the score and compare that and contrast with your original one. Now, of course, that is something like an AutoML will be doing, right? When you run AutoML, and we have done several sessions on AutoML so far, you can go back and take a look at one of those. What AutoML is doing is trying to do the tuning, right? At the end of the day, is not only selecting the best model, the best algorithm, right? But it would select the features and then run a tuning. So by doing this by hand, I am trying to tune it by hand and then test a few different settings to see if something improves or makes it worse, right? So again, this is just to show you guys that when you get to that more advanced analysis of your data, you know your data better than any tool, right? So you understand your data and you know your data better than anyone. So when you're doing your work, you probably will know exactly what kind of things you would probably want to search for, or what is the percentage for a split, right? If you are looking for fraud, and there is a very small percentage of people that are the fraudulent ones in a few places, you might want to tweak these splits, right? Instead of being 0.01%, you might go even lower because you know that you're looking for that, needle in the haystack, right? You're looking for that little exception down there in the tree. So there are a few things that you might tweak depending, again, on your use case. And then we're doing a scoring on the adding the supplemental columns. So supplemental columns, of course, is very important, very key for us so that we can keep that prediction. So the probability of 1 and probability of 0, right, which comes from the predict proba, right? So this is a trick where we are doing the prediction. We're predicting with test, right, with the X. So with that, we get the result is the prediction. Prediction is the guy's going to buy or the guy's not going to buy, right? 0 or 1. But then we're going to do here a predict proba to actually pick up the probabilities. With this command, we pick up the probability of 0 and probability of 1. And then we actually here merge those guys. So we now join them. So now we have everything. So if we were to look at, and then we can actually build the confusion matrix for us, right? And all of these analyses. So if we were to look at what is in this RASDF, right? So let's take a look at what this guy looks like, right? So I can add a z.show, right? Remember that z.show is what we use in our Zeppelin interface, right? In our Oracle Machine Learning notebooks, we use z.show to show what the pandas data frame looks like. So we can do that. Okay. So now I have the affinity card here, and then because I merged that data, if I go to the way to the right, I get the prediction. And I get the probability of 0 and probability of 1, okay? So that's guy saying, I predicted 0 because I had a 99% probability that this guy's not going to buy, right? So that's basically what this guy is doing. And then this guy had a 1 here because he has a 73% probability of buying, right? So then the algorithm, the model here assigned it a 1, okay? So that's how that data looks like out of this portion of the execution, right? So then to work with the confusion matrix is simply we do a cross, right, between the actual 0 and the predicted zeros, actual 1 predicted 1s, and we can see the confusion matrix. We can check the accuracy, AUC, and F1 score, and then we can see all of the nice charting that we put together to show the distribution between the target 0 and the target 1, right? So that's basically what it's showing you, and what is the optimal cutoff at that point under the AUC curve. Okay, so and then what we ended up doing is this guy is showing us the prediction details. Okay, so that guy was assigned 1, and the reason is this occupation, the occupation as professional was the one that had the most weight to indicate that this guy was going to buy, right? The second reason why is the household size, and the third reason why was assigned that was the Y box games, right? Something along those lines. So, and then finally we can materialize the test, right? Data into a table, and then we can use SQL as well to do the same kind of process. So with SQL you can get more fancy just because in SQL we are looking at that XML table capabilities. So because the return is an XML, we can play with it and just make it look like this, right? So you're saying customer ID number 002 is not going to buy, and these are the reasons why. Reason 1, reason 2, or reason 3, right? So that's what I wanted to show you guys. And again, as I mentioned before, if you were and had a 21C, like I have here as an example, right? If you had a 21C database running, then you would be able to open up and get the XGBoost classification example. And we've done a similar thing with it. We have added all of the components that we have added so far in our other classification algorithms, but this guy is going to be showing you the XGBoost algorithm, which is new for the 21C. So it shows you some of the new, we have some of the new links, but again, it's all doing SQL, right? So again, I'm gonna just go through the algorithm and show you guys here. So you have examples of the overrides for XGBoost. So you have the different types of trees that you can use, regularization parameters, the tree boosters, subsampling methods, iteration rounds, and from binary classification, you have the objective as well. And then these are the different XGBoost, right? So you have the XGBoost here on one side and the other, all using PL SQL, right, to build. And then it can show you all the different examples here for you guys to take a look at, okay? So again, if you have 21C, you'll be able to look at these examples using SQL again, right? And that was basically what I wanted to show you guys, okay? So we can go back to Q&A. I know we ran a little over, but any Q&A, Mark and Sherry, any questions?
Yeah, hi, Marcus. So Derek Cameron asked, when using AutoML, where can you view the settings that were selected?
Oh, great. Thank you, Cameron. So basically what the way now, we're working on it, right? Today, if you go to AutoML and then you create a new experiment, and let me select a project that I know has some experiments that we can go quickly over it. So when you have something already built, then what typically happens is you're gonna go and run the experiment, right? And once the experiment is completed, right now, today, right, the only way we have to see the settings that were selected when the model was built is going to be if you click on the model and then you create a notebook, because then the settings that you have, right, the settings that you have are going to be there, right? So they're going to be explicitly put in that notebook for you, right? So then if I go to notebooks, I can, check for my last update. That's my notebook that I just created. So I can scroll down and see that set of settings. We're working on trying to get it in a way as well to display that, right, for you there in the other screen where you're building it with AutoML. But basically, this is the way to check the settings on the AutoML UI when you're building it, right? If you're building an AutoML by hand, then after the tuning, you can actually see it. So if you're building it by hand, at the end of one of our examples that are in that exists in the these guys exist in our GitHub, you can see that you can print out the results of the evaluations, for example, from hyperparameters. So you can actually print out, say, these are the top two first, right, selections, right? So then it shows you, hey, I tried this guy and this guy was the best one, but I tried this guy as well with a class weight balance on, right? And it was not better than the first one, for example, right? So that's the other way to do that.
Okay. And the second one from Derek is he's asking, how can I compute lift for AutoML?
Yeah, you should be able to. I mean, not directly from AutoML itself, but then from the results, right? So the idea is once the AutoML builds the model for you, then it's just a model, right? So then you can go back to, and as an example, right, if you're thinking about SQL, we could easily go back to, putting the lift there as a regular model. At that point, once you built it, it is one of the models that is available for you. Now, sometimes it might be interesting for you, if you want to actually take not only the best model, right, but from AutoML, take the first two or three, and then you maybe tune them and then build, lift charts and then check them side by side. That might be an idea. So a lift shouldn't be any more complicated than what we're doing already with that code in Python, where we're plotting the AUC and things along those lines, right? But once the model is built, then you can just switch from Python to SQL and just type the same code that you normally do for putting the lift charts together.
Okay. And we have one from Hrishikesh regarding, as in BI servers, are the way to know which user used which template and the number of runs of that template for usage tracking and adoption. This is a feature that I think we would definitely like to have more details on.
Yeah. I think that's going to be talking about connecting to the behind the scenes, right? To what is happening with templates, because you can have personal templates and you can have shared templates. I believe you can, if you look at the notebooks, you can see the last update and updated by, right? So you can see at least who touched that, but not really who executed it, right? So I don't see the execution time. I see the execution time, right? The last time it was run. But yeah, you're right. So that's something that is more, in the admin side, right? Where you would like to see how many people are using how many of those templates, right? I think that's going to be definitely a good enhancement.
Yeah. All right. Well, that seems to be all of our questions for now.
Excellent. So, well, thank you very much, guys, and talk to you guys next week. Thank you, Mark, and thank you, Sherry.
Yeah. Take care.